Hi, welcome to our first problem. Imagine you have 10 bank cards and 3 of them are expired. We want to know the probability of randomly selecting 2 bank cards without putting the first one back, and both of them being expired. To solve this, we need to calculate the probability of the first card being expired and then the probability of the second card being expired. Given that the first one is expired, the probability of the first card being expired is 3 out of 10 because there are 3 expired cards out of 10 total cards. If the first card is expired, there are now 2 cards being expired, given that the first one expired is 2 out of 9. We multiply these two probabilities together to get the final probability, which is 3 times 10, 2 times 9, equaling 1 over 15. This means there is a 1 in 15 chance of both cards being expired if selected without replacement. Probability with replacement. Now let's consider the same problem but that with a twist. This time, after selecting the first card, we put it back before selecting the second card. This is known as selection with replacement. In this case, the probability of selecting an expired card remains the same for both selections because the total number of cards and the numbers of expired cards remain constant. So the probability of the first card being expired is 3 out of 10, and the probability of the second card being expired is also 3 out of 10. Multiplying these probabilities, we get 3 over 10 times 3 over 10, which equals 9 over 100. Notice how probability changes when we select with replacements compared to with other replacements. Slide 3. Coin toss outcomes. Let's move on to a different type of problem involving coin tosses. Imagine tossing a coin 3 times. Each toss can result in either a head, which equals 8 possible outcomes. These outcomes are head to head, head head tail, head tail head, head tail tail, tail head head, tail head tail, tail tail head, and tail tail tail. We're interested in the number of outcomes that have at least one head looking at the list. We can see that 7 outcomes out of 8 have at least one head, and only one outcome, tail tail tail, has no heads. This information will help us calculate probabilities related to these outcomes. Probability distribution for x. In this problem, we're defining a random variable x that takes the value 4. If we get at least one head in the 3 coin tosses, that's 0 if we get to no head. Based on the outcomes we listed earlier, 7 out of 8 outcomes have at least one head. Therefore, the probability of x being 4 is 7 out of 8. There is only one outcome with no heads, so the probability of x being 0 is 1 out of 8. This gives us a clear picture of the probabilities associated with the random variable x. Probability distribution table. Here's a probability distribution table for the random variable x. The table shows the possible values of x and their corresponding probabilities. X can be 0 with the probability of 1 over 8, which corresponds to the outcome of getting no heads, which means tail, tail, tail. X can also be 4 with a probability of 7 over 8, which corresponds to all the outcomes at least one head. This table is a concise way to present the probability distribution of x and helps it in understanding the likelihood of different outcomes in the coin toss experiment. Thank you.